I'm Greg Coleman. I'm co-founder and CEO at Sumatra, and we provide a feature platform that specializes in use cases with really strict latency and freshness requirements like fraud, security, personalization. And yeah, there's been some great discussions so far about DSLs, and I hope in the next 10 minutes I can contribute something useful to that conversation.
Great. Do you want to try and share your screen? And oh, you're all right. You're great. You're good to go.
Am I good? Okay, great. So the way I think about the feature engineering process is it really starts with an idea for a pattern or a signal in the head of a data scientist who then needs to implement it in some way that captures that intent correctly before they can evaluate whether there's lift from that signal in their model before putting it finally into production. And so as we as a community get better at supporting data scientists from that research to production step, there's great opportunities for us to support them earlier in the process as well. Which is really a question of developer experience, and language is not the entire developer experience, but it's a really kind of critical piece of it. And so, when I've looked around at feature languages out there, you really see a really wide variety of things from config files to interpolated queries to a lot of Python. I've even seen Clojure. And for us to have a good discussion about this, we kind of have to break it down in terms of what kind of transformation we're talking about. And so there's really different situations depending on whether it's batch streaming or on demand. And in particular, in the batch world, I think this is where DSLs get a particularly bad rep. And I think it's for good reason. It's because there's just a really wide variety of transformations we want to be able to do. It's completely open-ended. We have the luxury of time. And there's often existing pipelines that you want to be able to reuse. And so the kind of general interface that we've come up with as a community is to think of those transformations happening in some process that then eventually through a data frame API makes its way into the platform. And that's certainly how we built our own platform as well. And so not to say that DSLs couldn't potentially have some place there, but really where I have found the most interesting use for them is on the streaming and on-demand side of things. And so in particular, something that is a little different about the way that we approach things than other people is that rather than thinking about streaming as batch that's just going faster and faster and faster, kind of coming at it from the other angle of thinking of streaming as on-demand, but with state. And so as I'll show, there's some really nice things that you get from thinking about the streaming problem that way. But when you do, there's a lot of advantages to taking the streaming and on-demand transformations and thinking of them as having one representation, one unified language for expressing them. And so how are we to say if a feature language is good or bad? It really comes down to how are we empowering a data scientist to do their work as much as possible without having to phone a friend to an engineer to save them because of some platform shortcoming. And if we look at some concrete examples, so here's an example of a YAML, simple definition for an aggregate. There's a lot to like about this. It's concise, it's in the language of the domain, it's declarative. And then on the other end of the spectrum, we have something like this. This is an example taken from the feast docs, and there's a lot to like about this as well. It's very flexible, general purpose. It's has the full expressiveness of a general purpose programming language. And so we can kind of think of these as occupying different ends of a spectrum, from a high level of abstraction to a low level of abstraction. And so when we think about how do we make a good choice here, is it really just a matter of thinking how constrained our domain is, thinking about the skill sets of our users and just sort of picking a spot on the spectrum? But I think we can do better than that by thinking about what are the things we can push on to try to get the best of both worlds. And so, one way that I've thought about, approaching this and how we've kind of arrived at where we have is to, you can look at an example like the feast one again, and think about kind of what lives above the def and what lives below the def, right? So above the def, we live in what I would call, feature utopia, feature land of where great things happen, right? It's declarative, it's well typed, it's, amenable to static analysis and optimization and all good stuff, right? Whereas, below the def, it's opaque to our system, right? I mean, you can stick infinite loops in there if you want, right? And you have to worry about whether pandas in your critical path is going to be, fast enough, and package dependencies, all this kind of stuff that we don't necessarily want the data scientist to have to think about. And so the path forward that we found is really to just try to do as much as we can in feature land as possible. And so one of the mindset shifts that we have to make is to, from the batch world where we think of features as these like precious artifacts that, for good reason, they are the result of like expensive processes that we've arrived at to come to this thing. If we shift away from that to think about features as things that are a little bit more lightweight, right? Things that are composable, it makes more sense in the streaming and on-demand world. So rather than giving someone a new black box to put their transformation into, we can think of it as giving them a bunch of components that they can compose together to produce their final feature transformation that they want. So I'll make that concrete with the language that we've developed and are continuing to develop that we call Scowl. So here what you're seeing is a line from our language where we are doing a streaming join between our current stream and the login stream to find, for this particular account ID, when's the last time they logged in. And from that, we get a login feature, a last login feature. And then we can take that login feature and compare it to the current event time, convert it to minutes, and now we arrive at another feature, the time since. And then we can keep doing this again and again with a bunch of different transformations to achieve our goal. And so if we make these transformations simple enough, it gives us that flexibility to do whatever we want. Whereas at the same time, we also want to be able to get that level of abstraction that we're getting from some of those more concise representations. And for that, we have the ability to create abstractions on top of these features, right? So then you can take something like this minute since login and apply it in multiple situations where you can create multiple features depending on what entity you're passing in. And so you may be thinking, this is nothing special, like, lots of languages have functions, what's the big deal? But you have to notice here that what we're doing is we're actually introducing abstraction in the land of features with all those nice properties that we have, right? And further, it kind of takes us from this, from a feature reuse perspective, rather than thinking about feature reuse as sharing a global variable that I made, you're actually thinking about sharing the computation itself, which is a really powerful thing to be able to do across a team. So making features ubiquitous is partly about going deep, like I just mentioned, but I think about it also as going wide. And so what I mean by that is, if we look at the standard way of thinking about feature transformation, in most systems, it's entities come in and features come out, right? And these are different things, not to be confused with one another. But if we kind of look at what's at the margins of this, after feature transformation, feature extraction, we would have like what we might call transformations, things like one-hot encoding, imputing a missing value, stuff like that. Which eventually leads to our model. And so there's been some great discussion about exactly where that transformation should live. Should it be part of the model in that pipeline, or should it be part of the feature store? Well, if we start to view this entire thing as one big pipeline, we don't necessarily have to make a particular choice about where we're going to draw that line. We can think of this entire thing, including the model inference itself, as just a series of transformations from one set of features to more and more features. And in the space of use cases that we deal with a lot, especially in fraud and security, after model scoring, there's typically a bunch of business rules that are applied after the score. So things like whitelists, blacklists, other kinds of business logic that ultimately arrive at your decision. And we can think of that as a transformation as well. And we can even push to the left and say, even before the entities, we don't necessarily get every entity that we want from the calling service to our feature service. And data scientists can be really creative in terms of constructing their own entities that they want to aggregate over. You can take something like an IP and extract the CIDR block and concatenate that with a user agent, and now you have like an ad hoc device ID that you can track. And so we want to be able to bring that into that same pipeline. And so to confuse things further, sometimes this isn't a clean path from left to right always. There's often interleave steps of stateful, stateless transformation, aggregation, and so on that ultimately turns this entire thing into just one giant DAG, right? And so if we think about it this way, as just like one big DAG of transformations, we can do some cool things with this entire DAG. We can say, hey, now we can statically type check the entire thing end to end, right? Feature versioning now becomes something where we can just look at our dependencies, and when they're updated, we implicitly can recognize that our feature has a new version as well, right? All the investment we've made in logging and monitoring that has applied to features now applies to this entire DAG. And when it comes to online-offline consistency, which is something that we as a community focus on a lot, rather than just focusing it narrowly on this one part of the pipeline, it allows us to extend it to that entire pipeline. And so it doesn't mean that we always need to include every step of this in every process, but there's something really powerful when you can do that. And so you can run really interesting counterfactual experiments where you can change entities or features early in the pipeline and take that all the way through to the end of the pipeline to see what effect it will have on the ultimate decisions that you make. So from what I've said so far, very little of it has had to do with the syntax itself. So for us, it's made sense to actually invest in a full language with a compiler and parsing and all that in order to be able to support the other parts of the developer experience as well. So things like syntax highlighting and autocomplete. We've even made a REPL where you can take expressions written in the language and bring them directly to the data that you have to be able to see in real time what changes to those features make in terms of how they change the feature value so that you can get to that correct implementation as quickly as possible. So there's lots more cool things that can be done here. Tons more things we can talk about in terms of what makes for a good feature language. Things like type inference, what these things are very amenable to. Being able to support embeddings and JSON natively means like supporting lists and structs. Missing values are such a common thing in the feature world that we want to be able to speak them natively. So if you want to see how we've taken some of these ideas and incorporated them into our own language, our docs are public, so I encourage you to go check those out. Want to give a quick shout out to a few folks who are really helpful to me in thinking through how to present this material. And if you want to geek out on programming language stuff, come see me in the Slack. Thanks.
Great stuff, Greg. It's a fascinating talk, a very holistic vision for how we should build end-to-end machine learning pipelines.